problem is stated here, and to write the diagram, the best way to analyze this problem is to see that the forces involved all meet at this point, this junction point, so we'll call that the object, and there's a tension force going at that angle, a tension force there, and a tension force there, and these tensions are created by these hanging weights, so they'll be labeled, they're tension forces, but we'll label them as we see here as W2, W1 creates that tension, and W3 creates that tension. There's no reason to turn the axes in this case. It will not improve the situation for us. It won't simplify things, so we'll make X and Y axes conventional. So you should see for the angled tensions, there's each has a component on the x-axis, each has a component on the y-axis, and that's all been translated here. So the components for W1 are in red, for W2 are in green, and I want to calculate those components. So using this 35-degree angle, I'll use that triangle, and this relationship exists for the sine of 35, and there is a calculation of W1x, the x component, and then this relationship with 35 allows us to calculate the y component. So they are now in the diagram without the units. Those are newtons. I'd like to now get the components for W2, which are green, and even though it doesn't look it the way I've drawn it here, these are the only components on the x-axis, so they must be equal in magnitude. So W2x is 115, which means that triangle, the side up here, is 115. With an angle and a side of this triangle, I'll now calculate the y component for W2 and then W2 itself. The tangent of 50 is the 115 divided by W2y. So that means W2y is 96 newtons. And now I'll use the 50-degree angle in this 115 newton side to calculate W2. W2 equals 150 newtons. So we now have W2, which is one thing we wanted to get, and we have to remember that given was this force at 200 newtons, so that's W1, that is known. Now we just have W3. To get W3, that's on the y-axis. Let's use the net force equation for that. We know that because forces are balanced, there's no motion, no change in velocity. The forces must sum to 0. W3 is what we want to calculate. The two components from the angled tensions are also on the y-axis, and that's W2y would be 96, and that's upward, so it's positive, plus 164. And now solving this equation for W3, we see that W3 is downward, so it's negative 260 newtons. So that is the value of this third tension. And now we have all three tensions, and we are done.